it's Miss Klingstick, and today we are going to go on a chemical road show. So I'm going to be showing you some different experiments for you to see what a chemical change looks like. So we talked about earlier in the week what the difference between a chemical and a physical change. Remember, physical changes are when you have something and you apply the change, but the material stays the same. I have the same matter at the beginning and the end. But a chemical change is where I start with one type of matter, I apply the change, and then something new is created. Now, there are different things that let us know that a chemical change has happened, including bubbles, which means a gas was created, a temperature change, a precipitate being made, light being formed, a color change. All these things let us know that something new was created. So we're going to go through 5 different experiments, and I want you to try to see, can you identify what are the things that prove that a chemical change has happened? All right, let's get started. Okay, so our first experiment is called the Instacool. So what I have is I have a graduate cylinder, and I am going to put in here some distilled water. So water is H2O, but water we get from the sink is going to actually have some minerals in it, and that's not a bad thing. Minerals aren't a bad thing, but when we're doing experiments, we want pure H2O. So what this water is it's water from the sink that has been purified, and so that it's just H2O or water. So I'm going to do about 40 milliliters of water. There it goes. There we go. It's about 40. Yeah. Okay. Then what I'm going to do is I'm going to put my thermometer in. I'm going to add some sodium bicarbonate. Now, sodium bicarbonate is actually baking soda. In the cooking video we watched earlier this week, we talked about sodium bicarbonate, but it is a chemical. And so what we're going to do is we're going to add this into the water and see if anything happens. Again, we're looking for chemical changes. Okay, I'm going to stir it. Now, if you notice, there are no bubbles being created. All that's happening is that the sodium bicarbonate is being dissolved into the water. So right now I have not seen a chemical change. Okay, so I'm going to use my thermometer. I'm going to tell what the temperature is. So it looks like it's about 17 degrees Celsius. And when I touch it, it feels cool, but it's not like cold or anything. But now what I'm going to do is I'm going to add citric acid. Now, citric is like citrus that you would find in a citrus fruit like oranges or limes or lemons. And then the citric acid, so the citrus from that acid from that fruit would be added into an acid, and it creates citric acid. Citric acid is also what they put on the outside of candies to make them sour. So this is citric acid, is another chemical. So I'm going to take a spoonful of that, and I'm going to add it into my H2O and sodium bicarbonate mixture. So let's see what happens. Do you see that? So the bubbles that are being created lets me know that a chemical change has happened. When you see bubbles as a scientist, you need to think gas. The bubbles that are coming right now, that is actually a gas being created. So what I did is I had my solution of water and sodium bicarbonate and citric acid. When I combined them, they created something new. Now, to show you that a gas is being created, once my bubbles kind of go down a little bit, I'm actually going to use the gas that is produced to light this, or to push this flame out. It's going to blow it out. So let me show you. Okay, so I don't have any liquid, but with the gas, I am able to blow the candle out. So that is how you know that a gas is being created. Even if we can't see the bubbles, a gas was still created, and that is what creates the bubbles to come up. Now, another sign of a chemical change is a temperature change, either temperature going up or temperature going down. So again, remember at the beginning, it was a 17 degrees Celsius, and now it is actually 14 degrees Celsius. And when I touch it, it feels much colder. So that's letting me know that a chemical change has happened. And that is my Instacool. Okay, for the next thing in our chemical roadshow is we're going to be making elephant toothpaste. Now, I know you've seen those videos where it's like the ginormous explosion, and those are super cool. They're all over YouTube. Our elephant toothpaste is not going to look exactly like that. One of the reasons is we're not using as strong as strongest chemicals. Those people who do those giant ones, they have stronger chemicals. Also, they might have different combinations of materials that make those explosions bigger. So ours will not look that big, but it will look really cool still, okay? So what I'm gonna start with is I actually have 70 milliliters of hydrogen peroxide. Now what hydrogen peroxide is H2O2. So it's like water, except that instead of just one oxygen molecule, there's two. So 2 hydrogen and 2 oxygen molecules. You cannot drink H2O2, it is not the same as water, but it is something that you can buy at the grocery store. So I'm gonna add my hydrogen peroxide in here, okay? And then I'm gonna be adding in some liquid soap. Now this is stuff that you can get just like Dawn or stuff that you would use to wash your dishes. So I'm gonna add some in, about 2 tablespoons, kind of eyeball it. And then what I'm gonna be doing, I'm gonna swirl it around. Now if you notice, I don't really have any chemical changes happening. I'm just kind of making those two into a solution, mixing them together. What I'm gonna now do is I'm gonna add some food coloring. I'm gonna go with red. Boop, boop. Okay. I'm now gonna add in 20 milliliters of warm water. It's actually a little bit warm, so I'm gonna use this. 20 milliliters of warm water. Again, I'm using distilled water to ensure that I don't have any minerals in my water. It's so tricky to get this, huh? All right. Perfect. I'll go with that. All right, so I'm gonna add that in. Okay. Again, I'm gonna swirl it around. Again, I have bubbles. That's from the soap. It looks kind of like blood, huh? Okay, so now what I'm gonna add is I'm going to add in potassium iodine. Now, potassium is the stuff that you find in like bananas and potatoes. It's actually known as a metal. It's in our periodic table. But this is a potassium iodide, so it's mixed with iodide. So I'm actually gonna now add this in and we're gonna see if we can have any chemical changes. Here we go. All this in. You can already kind of see it's starting to turn a new color. It's turning yellow, oranges. So that's another sign about a chemical change. So that's one. Let's see what happens. I'm gonna let it sit. See, what's it doing? Do you see that it's starting to rise? Why do you think that's happening? Hopefully you think, oh, bubbles are being created, and those bubbles mean that it's a gas. So what's happening is that we had a chemical reaction, a chemical change, that when those types of matter got involved with each other, they mixed together, they have a chemical reaction. And we know because 1, there was a color change, but 2, bubbles are being created. And if there's bubbles, that means there's gas. Now, I'll also let you know, if I put my hand right here, it's really warm, like warmer than that water was. And so that's another sign. There is actually a endothermic change. Endothermic means that exothermic. Exothermic is that heat is being given off. The one where it was cooler that we just saw, that's endothermic. It got colder. So we have, ooh, it's hot. That is an exothermic change because heat is being produced. So all of these are signs of a chemical change. Isn't that so cool? Oh, it looks so cool. And that's elephant toothpaste. Okay, starting the recording again because I wanted to show y'all. Look how it looks. Isn't that crazy? She just keeps going. Such a cool chemical change. All right, so the next one we're gonna do is burning salts. So what I have here is I have ethyl alcohol. This is like the stuff you're gonna find in your hand sanitizer that kills the germs on your hands. And so it's pretty viscous, it looks like hand sanitizer. So here's ethyl alcohol. I'm gonna put some in each Petri dish. Now we talked about chemical properties. Chemical properties are if something is able to change chemically. One of the chemical properties we talked about is flammability. Now, ethyl alcohol has the chemical property of being flammable. So this material will light on fire. So what we're gonna do is we're gonna light the ethyl alcohol on fire, and we're gonna be adding in some materials to see if there's a chemical change. So the first one is borax. Borax is actually something you can find in like laundry soap. So we're gonna add that in. The next thing we'll add is calcium chloride. So that's calcium and chlorine mixed together, makes this solid. And then the third thing we're gonna add is actually, it's a mixture of three things. The first one is copper sulfate. The next one is sodium chloride. And the third one is potassium chloride. So again, we're seeing that potassium. So we're gonna add that in and see if there's any type of chemical change. Remember, color, more being produced, those types of things. All right, I'm gonna turn the lights off. All right. Okay, so we're gonna do the borax first. That's this one. So, as you can see, my ethyl alcohol is flammable, and so it is lit on fire right now. And what I'm gonna do is I'm gonna sprinkle in some borax, once you see. First, notice what color it is first. Okay, and let's see if that color changes. You see it? Turns orange, isn't that cool? So when it mixes with the borax, it has the chemical reaction, the chemical change that makes it orange. When that color change, let us know a chemical change has happened. Okay. All right, we're gonna move on to the calcium chloride. All right. So again, lighting my ethyl alcohol on fire because it is flammable. Okay, now I'm gonna take my calcium chloride. Again, look at the color. Okay, here we go. See how it turns it red? That lets me know that what type of change has happened? Chemical. It's a color change. Isn't that cool? That one went out. Now, you can't really see it, but I can hear it and I can see it. There are bubbles being produced. Now, we know when there are bubbles, as scientists, that means that what is being made? A gas. And so, because now I've seen a color change, and there's gas being created, I for sure know that a chemical change is happening right now. Super cool. All right, I'm actually gonna push that to the side. Okay. Okay, it's gonna keep going, but the next one I wanna do is the trio, the three things. So I'm gonna light the ethyl alcohol on fire again. Okay, now, watch this flame. Let's see if it changes colors when I add in these new materials. Did you see it? Here, let me do it again. Did you see the flames turn like green and blue? Isn't that the coolest thing? So that color change lets me know that what type of change is happening? Chemical. And that is the burning salts. Isn't that the coolest thing? Ooh, this one's going. Chemical changes are the best. All right. Alrighty, so the next one we're gonna do is called the iodine clock. This is one of my favorites. So here we go. So what I've got is in my first container, I have some vitamin C. So vitamin C is actually a nutrient that you can take. These are actually vitamin C tablets that I actually take. I just crushed one up. Vitamin C can come from citrus. So again, talking about like oranges and limes and stuff. But vitamin C helps you keep your immune system healthy. And so that's all this is vitamin C. And then what I'm gonna do is I'm going to add in 120 milliliters of distilled water. Let me go get a rag. Okay, so I've got my distilled water right here. It's just a little warm. It's not like super hot, but I'm gonna add 120 milliliters. Okay. And I'm gonna stir that up. And so you can see there aren't any bubbles being created. So this isn't a chemical reaction. It's just me dissolving the potassium into the water. Okay. Then in this container, I have cornstarch. Cornstarch is like what we saw in the video from yesterday, or the presentation. But cornstarch, you can use it to cook. It's made out of corn. You can use it to cook. You can eat it. It's no big deal. But cornstarch is what's in there. And I'm going to add 40 milliliters of distilled water into this one. Okay. And then I'm going to add in 100 milliliters of hydrogen peroxide. Again, that's H2O2. All right, so I've already added in 40, so now I'm going to add 100, so I should get to 140. Whoop, right there. Okay. And again, got no bubbles, no real reactions, nothing that lets me know a chemical change has happened. We'll just have that mixture now. So what I'm going to do first, this is iodine. It's 12 milliliters of iodine. I'm actually going to have this iodine disappear into my vitamin C mixture. Ready? Watch. Where'd it go? Oh, isn't that cool? So I always like to say magic is the real science, or science is the real magic of the world. I mean, that's truly true with this one. So what actually has happened is the iodine is reacting with the citric acid and the water, and so it doesn't actually disappear. It's a chemical reaction. So we just saw a chemical change. That iodine had a dark color and it changed to a clear color because of its reaction with the citric acid. All right, so now what I'm going to do is I'm going to add in this mixture to this mixture in this cup. Okay, and what I'm going to do is I'm going to just pour it back and forth. And so what I'm doing here is I'm, giving it some time. And then, because again, this is called the iodine clock, so we got to be patient. But I'm also adding in more oxygen. Let's see. I'm hoping there might be a color change, but we'll just have to wait and see what happens. Now, this does take some time, so I might speed up my process here with the editing magic, but we'll see. Keep watching. The more I pour it, the more oxygen. Sit for a little bit, see what happens, if anything happens. Let it think. Let's keep going. Keep watching, it's gonna change. Watching. Did you see it? Every time it's so cool. So we just had a major color change, and that lets me know that a chemical change just happened. Isn't that the coolest thing ever? So this brown liquid is a new substance. I started with my 2 substances in the small container, and it has chemically changed into something else. Coolest thing ever. All right, so this is the last show of our Chemical Roadshow. So we have seen chemical changes that let out gases, that also let out bubbles, which would be the gas. They had color change. We have had heat or cold, so that's a temperature change. We've seen lots of things that have created a chemical change. So we have one more that I want us to see, which is a light change, where light is given off. This is kind of like a firework. So we're going to actually produce light because of a chemical change. So this is, what we're going to do is I'm going to take 35 milliliters of potassium for cyanide. So again, we're working with potassium. We've seen it a couple times. Potassium for cyanide. I'm going to get 35 milliliters. I'm actually going to do a little too much. Oh. Perfect. All right, 35 milliliters. And then into this, I'm actually going to add in 3.5 milliliters of hydrogen peroxide. So just a little bit. Oh, oopsie. All right, so my pipettes. 3.5 milliliters. Don't need a lot. Isn't this so cute? And there we go. Perfect. Okay, and I'm going to add this into here. Okay, swirl that around. Okay, and then in my other graduate cylinder, I'm going to be adding in this energetic light solution. I'm going to add 35 milliliters of that. And you can kind of see it's much thicker. So if we think about it compared to this one, which one is going to have a higher density? Hopefully you said this one because of the thickness. This one is definitely more dense than this one. Okay, so I'm going to add this into my flask. Flask is going to be used as a good mixing tool. Okay, and then what I'm going to do now is I'm going to turn off the lights. Okay, and now I'm going to add in my energetic light solution. Let's see what happens. Do you see it? Whoa! It's a glow stick. So we just actually created a glow stick in a glass. You can see, isn't that so cool? So light was created, and that lets me know that a chemical change occurred. So whenever light in a glow stick happens, that's like a chemical change. Isn't that so cool? Huh? And we just made a glow stick with a chemical change. All right, guys, that is the end of our Chemical Roadshow. I hope you enjoyed all of our chemical reactions, and I hope you're excited to do some of your own, because we will in class, or online if you're online. But I hope you guys enjoyed it, and I hope you're excited for chemistry, because it is super cool. And just remember, science is the real magic in the world. Haha. Okay, bye.